right, welcome everyone to mobile app development with React Native. My name is David Malin, and this here is
Jordan Hayashi.
And this is a course that assumes as background only something like CS50, which is Harvard's Introduction to Computer Science. But more generally, if you haven't taken that particular course, prior programming experience in most any language should suffice. The focus of this class, of course, is going to be on mobile app development. And the interesting thing about this space is that it's been changing pretty rapidly. It wasn't all that long ago where none of us actually had smartphones in our pockets. And so the landscape has been changing particularly quickly. And it's getting better and better. If you've done any app development on mobile devices or any web development on mobile devices, early on we pretty much just had like HTML and CSS, maybe some JavaScript for interactivity. Then lots of libraries came onto the scenes that kind of, via CSS and JavaScript, gave the appearance that you had a mobile-like application on your phone, but the user interface wasn't all that good. And you could tell that this isn't really native. That is code that's written in Objective-C or Swift on iOS or in Java for Android. And something always kind of felt a bit off. And so you could learn any one of those languages or pick up the various toolkits that exist to write native software. But it's a decent learning curve. And if you're running a company or writing an app, you had to generally pick and choose. Do I want to target Android? Do I want to do iOS? Or do I essentially want to do twice as much work? And so that alone could be a potential hurdle. And then there were these other libraries that allowed you to sort of approximate the experience of writing your code once and then run it on both platforms. But there, too, you could always kind of tell that something wasn't quite natural for the particular device. And then more recently has come onto the scene a number of new frameworks, particularly React Native, an open source framework popularized by Facebook that really actually now enables truly native cross-platform development while using JavaScript to rather stitch things together and then leaning on the framework to provide you with those truly native user interface widgets and other features that you would come to expect from those various languages. So what we'll do over the course of this semester is really dive in deeply to mobile app development, but specifically building on top of this popular framework. You might have heard of React Native or React in the context of web browsers, which has been around for some time as well. And so a lot of those paradigms that folks have been using for a few years now on laptops and desktops is now available with additional features in a mobile context especially. So today we're going to dive in quite quickly to JavaScript itself. If you have a bit of background in that, that's great. We'll hopefully fill in some gaps along the way. And we'll also look at some of the more advanced features both tonight and next week as well, particularly ES6 or ECMAScript 6, which is essentially the latest version of JavaScript. And with it, some new syntactic features and programmatic capabilities. A week after that, we'll take a look at React itself and JSX, which rather commingles code with XML or a markup language, if you're familiar. And then look at some of the particular features and UI features that you get with a framework like React.js. Components, props, how you deal with state, how you can actually stylize things, get user input, and create views, if you're familiar with paradigms like MVC, Model View Controller, where view governs what it is the user is seeing and interacting with. We'll take a look at debugging techniques, particularly for a mobile platform, which might not necessarily be obvious if the device you're working on is here and the device you're testing on is here. We'll give you some tools and techniques for that, focusing ultimately on data and navigation, how you can actually get users around in your applications, and then looking at a popular third-party tool and framework called Expo, which actually makes it even easier to develop for this particular environment and get started and get work done quickly. Looking at Redux and state management, again, more generally, performance tuning of your applications, and then finally, how you actually get this thing off of your laptop or desktop and off of just your phone and onto other phones and mobile devices. And we'll apply all of these lessons learned, and the real challenges and the hands-dirty portion of the class will be by way of the course's projects. 3 of them assigned, specifications from us that spec out exactly what it is you should aspire to build. And then the class will culminate with a final project where it'll be up to you to design, to propose to design, and ultimately implement most any mobile application atop React Native as you might like. Without further ado, let's dive into an overview of the class itself, as well as then JavaScript. Let me turn things over already to Jordan.
Great. Yeah, thanks for the great intro, David. Cool. So quick few things about the course itself. You can find the information on the website. I emailed you all the link earlier today. On it, there's a link to the Slack, which is what we're going to use for like pretty instant communication. You can create groups amongst yourself, and we'll use that for any quick tidbits we might have to send out. And then additionally, we have our staff email that's linked as well, which is how you can just email the staff directly. Cool. And so a little bit about lectures. We'll have a short break about halfway. Get up. You can use the bathroom. Go rest your legs. If you have a question at all during the lecture, feel free to just shoot up your hand or interrupt me directly. concepts constantly build on each other, so it's pretty important to learn everything up to a certain point in order to build off of it later on. And if something isn't super important to know and you ask a question about it, I'll let you know, so don't worry about asking dumb questions. And the staff will be monitoring the Slack during lecture, so if people online have any questions, feel free to post there, and the staff will interrupt me. Another thing, I love live examples. I think the best examples are created on the spot. And with that comes a little bit of risk. So live coding does have risks. If I make a mistake, feel free to correct me. I have some candy in the lectern. So if you correct me, I'll give you some candy. For those online, sorry you don't get candy, but you can have some glory. Cool. Let's start talking about JavaScript. So JavaScript is an interpreted language. So I posted a little bit in the Slack earlier asking about most comfortable languages. Most of you guys were saying JavaScript. But I know those of you who took CS50 might have some experience with C, which is a compiled language. So JavaScript is not compiled. It's actually interpreted. So an interpreter will read line by line and execute that code line by line. Each browser has built into it its own JavaScript engine, which either interprets the code, it might do some magic with like some just-in-time compilation. But for the most part, it's just reading your code line by line and executing it. Each browser actually has its own engine, and they're named. So Chrome is called V8. If you've heard of Node.js at all, it also uses that same Node V8 engine. Firefox has SpiderMonkey. Safari has JavaScript Core, Chakra for Microsoft Edge and Internet Explorer. You don't really need to know these names, but it's a little bit important just to know that different ones exist. Because JavaScript actually is built off of a standard. The standard is put out by ECMA, which stands for the European Computer Manufacturers Association. That association is, they're in charge of just putting out a spec, meaning, hey, I know you guys have this language, but this is exactly what this language needs to do. And for every single function, this is exactly how this function should behave. And so each of these browsers, the engines in the browsers, actually implement this standard. But there are some functions where the standard is a little bit hazy on, or maybe it doesn't even define this particular function. And there's no hard line of exactly what that function should do. So they may differ for anything not defined by that standard. Cool, and some syntax. Let's actually hop into code directly for this. So let's do. Cool, and the way that you declare variables in JavaScript, there's actually 3 different ways. We'll talk about that a little more later, but for now, we'll just use this keyword called const. So if I wanted to declare a variable, I'd just say const. So give me a variable called first name. And I can give it any value I want. So let's just call it my first name. So you notice I have a string literal there. It's using double quotes. And then I end that statement with a semicolon. I can also do last name. And if you notice this time, I still have that string literal, but this time I'm using single quotes, because in JavaScript, there's really no difference between double and single quotes. You'll also notice I omitted that semicolon, which in JavaScript is OK. Semicolons are actually optional. Cool. So say I wanted something that was not a string. I can just give it a value, like 42. So in C, you might see something like, give me an int, or give me a string, or a char star. That you're declaring types right away with C, but for something like JavaScript, you actually don't have to do that. We can also do arrays. And we can just declare them inline like this. And I can have So if you notice, I actually have 3 different types all in this array. So I have a string, I have a number, and I have a function. And this is perfectly fine. JavaScript doesn't really care what you've thrown in an array. You can have all sorts of different variable types. And so say we want to access those things in an array. Anybody care to guess exactly how I would do that? So say I want to execute that function. How might I go about doing that? Any guesses? Yeah?
Array of 2.
Yeah, exactly. Array of 2. So if you're familiar with other languages, a lot of them have the same syntax for indexing into an array. And so since we have 3 things in this array, we do what's called zero indexing, whereby the first index in that array is called the 0th index. And then you count from there. So we have 0th here, 1st, and 2nd here. And so say I wanted to access that function, I just do array 2, and I get that function. And say I now wanted to execute that function, I can say execute it like that. So this is something that you might see in other languages, but JavaScript, you can do it as well. You can just grab that function out of that array and execute it like that. Say I wanted a for loop and I wanted to console log everything in that array, I can do it just like, almost like C. So I can do for, this time we'll use let for the variable. We'll talk a little bit more about that later. So I can start at 0, while I is less than the array's length. You might see me, my personal preference is to omit the semicolons, but you might read something online that has them. It really doesn't matter all that much. And so this line of code here, you might have seen a for loop in other languages that you've used. So this one is just saying for, give me a variable that's called I that starts at 0. And while it's less than the number of values in that array, array.length, just keep incrementing it. And then at every single time, console.log, which is JavaScript's print function, whatever that value in that array is. So we can actually run this. And as you see the first time, line 12, where we say index into that array to the 2nd value and call it, that's what's printing hi. And then this for loop here will now print string 42 and this thing called function, which is this function. Cool. Any questions on syntax? Yeah?
Does it matter if you have that 3rd comma after your?
It does not matter. So the question was, does it matter on line 9, that comma at the very end? And so JavaScript allows you to have trailing commas, meaning in arrays, objects, or even function calls, you can actually have extra commas, and it doesn't matter whether you have it there or not. It's optional, just like the semicolon is. But were I to omit the comma here and try to run that, I'm going to get a syntax error as expected. Cool. Any other questions? Great. So back to slides. So types. We talked about types a little bit earlier, and I'm just going to talk a little bit more about them. So JavaScript has what's called dynamic typing, meaning given a variable, it has no type associated with it. So just like I said, give me a string called, or give me a variable called first name and set it equal to a string, I could actually change that later to, say, a type number or a Boolean or anything like that. And JavaScript is fine with that, just because it has those dynamic types. And there are a certain number of primitive types. Primitive types are types with have no methods, and they're immutable. And so undefined, null are 2 of them. Boolean, everybody should know Boolean, true or false. Number, 1, 2, 3, negative 1, 2, 3. It has no floats, so 0 and 0.1 are both of type number. String, which are the things between the quotes. And then symbol, which is something that's new in ES6, but we're not going to talk about it, nor are we going to use it. And then everything else is an object, and we'll talk a little bit more about that later. Cool. And so a lot of languages have this thing where you check a different, where you change one type to another type. So since JavaScript is dynamically typed, we have this thing called typecasting. So coercion is the act of changing one type to a different type. And there's 2 different ways you can coerce these variables. So say, as an example, we have this const called x, and we give it a value of 42. Say I wanted to change that value to a string. There are a couple different ways I can do it. There's explicit coercion, there's implicit coercion. So explicit is, hey, I'm just going to tell you exactly what I want by wrapping it with the type that I want and give it to me. And so that's being very explicit with what I want. And so the example of that would be, say I want to get a string from that value x. I just wrap it with capital string, and it pops out 42 as a string. There's also a way of doing it implicitly, which is I'm going to rely on the behavior of JavaScript in order to get this to a string. And so say I want to add 42 to empty string. That wouldn't really make sense if I wanted to have a number, but since 42 is easily castable to a string, I can say, hey, give me 42, add an empty string, and I expect to get back something of type string. That is called implicit coercion. And so how might we go about comparing? Oh, yeah, question.
Is the string passing in x the same as x.toString?
Yeah, so another way would be to invoke that. So the question was, what about x.toString? And so yes, another way to get from a number to a string would be to invoke that method on the string, or on the number, sorry. Cool, and so how might we go about comparing values? So in most languages, you can compare values with a double equals, but JavaScript has this thing called triple equals. So there are two different ways of comparing equality. There's double equals and there's triple equals, where double equals will actually coerce the types, and triple equals require that the types match. And so let's play with that a little bit. So say I have this value, and I want to know exactly what type that is. So there's this operator called typeof in JavaScript where I can invoke this. And that will give me the type of whatever that variable holds. So if I were to run this code, then it would say number, because that is the type. So right now, in order to execute my JavaScript, I'm using this thing called Node, which, as mentioned earlier, is basically a command line runtime for JavaScript, which is built off of V8. You can actually also use the built-in, any browser has a console where you can also just type JavaScript directly in there. So if I were to open up the tools on Chrome, which is my browser of choice, I actually get this, which is a JavaScript console built into all of these browsers. So if you guys are using Chrome at home and you want to follow along, you're welcome to open up the developer tools here, go to console, and you have your own JavaScript interpreter here. So say I wanted to do that things where I do const x equals 42, and I wanted to get the type of that variable, I can just do type of x, and it will output that number. So there's a little bit of a caveat with this, where this might surprise you. So who thinks they can guess what this will output? First of all, what should it output? So if we remember back a few slides, we talked about all of the different types. One of them is undefined, one of them is null. And say I want to get type of null. So what should it output? Yeah? String? Why would you say string?
You put console log it, so it's probably string.
That's a good guess. So basically, the answer was, so if you can console log it, it must be a string. And while that is correct, most of these types can actually be cast to strings. So we talked about implicit versus explicit coercion. And the way that console log works is it actually will turn these numbers into a string in order, or turn these values into a string in order to console.log them. But it doesn't necessarily mean the type of that value itself is a string. Yeah?
Null.
Yeah, so the null. So we would expect type of null to be null, since null is actually a primitive type. However, this actually returns object. So JavaScript does have some strange behaviors. This is one of them. And people often ask, hey, like, we're on ES6 now. Like, there have been 6 different versions of JavaScript. Why don't you just change this to be null? And the answer that ECMA gives is, well, the whole internet would break. And so a lot of these, each new version of ECMAScript should definitely be backwards compatible with the previous versions. Otherwise, say I put out a website tomorrow, if somebody comes down and changes a JavaScript spec, then my website might break. And so a lot of websites actually rely on this to be true. And therefore, if a breaking version of ECMAScript is released, it might actually just have unforeseen consequences. So this is just one of the strange JavaScript gotchas. Cool. So another question might be asked. A good question would be, so when should I use double equals versus triple equals? And people generally say you should never use double equals because that means you have to know exactly how every single thing coerces. And not only you, but every single person who reads your code should know what all of these values coerce to. And some of them might be somewhat surprising. So we have a chart here that talks about the JavaScript equality table. For those of you who have the slides open, you can click on that link, and it will bring you to the repo that has this. Basically, some of these strings are somewhat strange, like how empty array is double equals to false, which doesn't really make a ton of sense. A lot of these don't really make a ton of sense, and basically never use that double equals because it might have some strange behaviors. Cool, so moving on with coercion. So we talked about coercing things into other types, but how about if we're getting to bools? So JavaScript has these things called falsy values. Who can name a falsy value? So a falsy value is any value that, if cast to a bool, becomes false. 2? So 2 is actually truthy. So every number except for one number is truthy. Well, 2 numbers, actually, yeah.
0.
So 0 would be one of them, yeah. Not a number, which is actually a number of type number, is also a falsy value. Who can name another falsy value?
Blank.
Blank what?
Or empty.
Empty what?
Empty array.
Empty array is actually truthy. False is another one. Undefined, null. So those are the 5 falsy values. So who can name some truthy values? Somebody said 2, which is a valid one. 3, 4, every other number other than 0, -0, not a number. Empty array is also another truthy. Empty object. And literally everything else. So anything other than those values right there are truthy. Cool, so objects, arrays, functions, objects. It looks like I put objects twice there, but I actually put it 4 times. So JavaScript has this weird thing where if it's not one of those primitive values, it's an object. And so we'll talk about this thing in a little bit called prototype inheritance, which talks about how these objects inherit from each other and how they actually work under the hood. But first, let's compare those 2 types. So we talked about primitives earlier, which is who can name some of the primitives? Null, undefined, number, Boolean, string. And symbol. So good, you got them all, nice. So everything other than those primitive types are actually objects. So primitives are immutable, which means if you want to change them, you're actually replacing them with a new value rather than actually changing them themselves. Whereas objects are not; they're actually mutable. So who knows what storing by reference means? So storing by reference means we actually store a reference to this object thing, and we can actually change what is held there without actually changing where that thing is located in memory. We'll talk a little bit more about that in a second. But the opposite of that would be storing something by a value, which is what happens when you have primitives. So like I said earlier, primitives are immutable, which means once you create a primitive, it can't actually be changed. And when you want to change something, you actually create a new primitive and replace that old one. Whereas mutable things are actually stored by reference, and you can actually change that object. And so let's play with that a little bit. So there are a few different ways to create an object. One would be this way. So just saying, give me a new object. And so now O is this new object thing. And say we want to start populating that object, we can do O dot first name and assign that a value. O dot last name, assign that a different value. Notice that I have strings with double quotes and single quotes. It doesn't matter. So something other than a string, we can do a Boolean, so is teaching. And we can assign that to true. O dot greet, and we can give that a function. So that would be one way of creating a new object, is to use this new keyword along with capital object, and that says, hey, give me a new object, and I'm just going to fill it up with these values using this dot notation. Another way to do that would be what's called an object literal. So I can just do open curly, close curly, and that gives me basically a new object. This is actually the preferred way over that old new keyword with object. Mostly because A, it's easier to read, and, well, mostly just because it's easier to read. And so I can start filling those values in with O.firstName. And another way to index into these objects is to do O last name. So notice I use brackets there, which means inside this bracket, I'm going to have some value, and that value is going to be that key of that object. So I can do same thing here. And say I actually wanted to use not a string literal inside these brackets, I could also do that. So I could do is teaching, and do O, and then pass in this variable here with a value of is teaching, and that will set that key. And then say I want to do O of greet, and give that same function. Cool, and so those objects are basically the same. And last, we can actually put everything in line. So we can do this. Cool. And so those three objects are basically the same thing. It's just three different ways of declaring objects. You can also nest objects. So say I wanted an object within an object, that's also fine. Say I want to do something like this. That's also fine. So that's an object within an object. Any questions with that? Cool. Let's actually, yeah.
Do the elements of the objects all have to be like labeled with strings? Like a keyword number, say, would that work?
So anything here is interpreted as a string. So say we were to do like this. That would be basically 1 as a string. So this value here will be cast as a string, and that's what will be used as the key. So the question was, like, can we use numbers or anything other than strings as keys in objects? And the answer is kind of, because everything will just be cast to a string. But yeah, great question. Just actually copy and paste this into our browser, and we can confirm that it works. And so how might we go about getting those values back out? So it's basically the same way we got them in. So if we do dot, we can see, oh, this is the browser saying, oh, these are all the keys of that object. So I can do o3.address, and it'll give me back that object. And so say we want to get this number out of here, how might we do that? Yeah, exactly, dot number. Alternatively, we could have also done this and gotten the same thing. Any questions with objects? Yeah?
Is there like a conventional way to do that, or is it just kind of like preference?
To do what?
Just between like dot number and one with, like between the first way and the second one.
Cool. Yeah. So the question is there a conventional way to get values out of objects? Generally, the convention is to use that dot notation. So say we wanted o3.address dot number. The convention would be use the dot both of these times. But say we didn't know exactly what we wanted out of it, we could. So say we had this. Something like that, where we had some dynamic key, where the key we didn't actually know. That's when you actually have to use the bracket notation, where we have o3.address, and then we pass into it that key. Since key is a dynamic, since it's a variable, we don't know what it is, we have to then use that bracket notation rather than the dot. But great question. Was there, yeah?
You cannot do O.1, for example, and then set that to a value, you get a type error.
So if we did O.1, yeah, so O.1, 1 here, since we're typing it here, is a number, and we cannot set keys to numbers. But if it were in object literal like this, it considers this not to be a number, but rather a string.
You can use the array assignment by putting brackets around the 1 and passing it as a string. So you can do O dot, or brackets, quotes 1. O dot, open
Curly braces.
heart bracket, or braces, and then quotes 1, and then set that to a value.
So I think you mean this. Yeah. And I believe you can also do this, because that will get cast to a number, or I mean a string. Yeah, any other questions? Cool. Yeah.
So if you have the number one inside the bracket notation versus the string one inside the bracket notation, they'll be treated as the same keys.
Yeah, so the question is, what is the difference between this here and this here? The difference is anything between the brackets will get coerced into a string. And so since this is already a string, it's just that string 1. Since this is not of type string, it actually gets implicitly coerced into a string. And so like we saw earlier, if we did 1 plus some empty string, we get back the string 1. So this becomes a string 1, and it will index into that. Whereas this number here, so if we did o3.1, that 1 does not actually get coerced like it does between the brackets here. So JavaScript is basically saying, hey, this doesn't really make sense. I need a string here, not a number. Cool. Any other questions? Great. So let's talk a little bit about this thing where I was talking about mutating objects. So say I had this object, so in it we had A gets A, B gets B. So say I wanted to change A to be something else. How might I do that? Yeah? Yeah, so I can update this to be anything else. Cool, but say I actually did this. Anybody care to guess what would be console logged here? So basically what it's doing is we're creating a new object, storing it in O. This object has two keys, A and B, where their values are A and B respectively. I'm creating this new object called O2 and assigning it a value of O. I then go reset O, not O2, but O.A to be a new value. And now I'm going to console log O2.A. Anybody care to guess what this is going to console log? Yeah. So a guess is A. What would be the alternative guess? New value. Yeah, so let's run that. So we get new value. And so I talked about this thing called passing by reference and passing by value. So basically what's happening here is that O is being said, hey, give me a new object somewhere. And then store inside of it A and B. And then O2 says, hey, give me another object and set it to O. And rather than creating a new object with the same keys and values, it's actually pointing to that same object. So this is a case where things are getting stored by reference rather than by value. Meaning, so in CS50 we talked a little bit about pointers, and this is the exact same concept, where these objects are not stored as entire serialized objects, but rather as references to these objects in memory. So O and O2 are both referencing that same exact object. So when we go back and say, hey, update O.A to be new value, it's changing this object here, and still O and O2 are both pointing to that same object. So if I were to have updated O2 here and console logged O.A, we would get that same result, because O and O2 are still both referring to that same object in memory, and we're still updating that object here. Does that make sense? Yeah.
So what if you wanted them to be different? Like, what if you wanted it to not point to the same thing?
Yeah, so the question is, what if we wanted them to have the same value but be different references? How might we do that? There are two different ways. One, the more annoying way would just be to type the whole thing out again. So now we're guaranteed that O and O2 are going to be different references to an object that is basically the same. And another way would be to, there are multiple different ways to do this. The most common way in pure JavaScript would be to do this. Whereby object.assign is basically saying, hey, pass into me a bunch of arguments, and every single argument I'm going to merge into the previous one, those keys and values. And so this is saying, give me a brand new object. So I'm using the object literal here to mean a new object, and then merge into it all of the keys and values of this object called O. And so this is basically saying, give me a new object, and then set all of the keys and values of O to be in there. So this is the way of cloning an object. But say we actually did this. So what do we expect this to now print out? So we mentioned that line 9, we're taking the keys and values of O and merging those into a new object. And then at line 11, we're taking O2, getting the dot object, so accessing the value with a key called object, and then setting that object's key called key to a new value, and then now console logging O.object.key. Yeah. Yeah, so the guess is new value, and that is absolutely correct. So line 9 here is doing what's called a shallow copy, which is just grabbing the keys and values of some object and just setting those blindly into some other object, as opposed to what would be called a deep copy, where that would take the keys and values, and then if the values are objects, it would also take those objects, keys and values, do that recursively, and basically get every single layer deep clone. But since object.assign just takes the keys and values dumbly, if we have an object in there, update that object's key. O.obj and O2.obj are still referencing that same object in memory. So since we mutated that object, it would update in both O2 and O. Does that make sense? Great. Any questions about this? Yeah.
How would you do a deep copy?
So how would you do a deep copy? That's a great question. There are multiple different ways. So most people would say use a library, meaning rather than implementing this thing on your own, just take somebody else's implementation. But let's actually do that. That's a good question. So how would we do a deep copy? So I know we haven't talked a ton about JavaScript yet, but let's actually try to do this together. So let's call a function deep copy, and we're going to pass into it some object. And how would we implement this if we're guaranteed that no objects have values of objects? Meaning we are guaranteed not to have objects within objects. How might we do this? Yeah, so we can check for the type of every key, but if we're guaranteed that no values are going to be objects, we can just do a shallow copy, right? Yeah.
So check every value, and if the value is immutable, we have to recursively deep copy that.
Yeah, so hold that thought. Let's actually implement this as if we know that there are no objects inside of objects. So if that were true, we could just return the shallow copy, right? So object.assign. So this would be a perfectly valid implementation if we knew that there's no such thing as objects within objects. But since there are, we're going to have to do some magic here. So can you repeat your recommendation again?
So check if any of the values is an object, then we can't just take that value into a new object because they reference the same object.
Mm-hmm.
So we need to deeply copy that object instead of just taking. So we need to call deep copy on that object. If there's a value.
Nice. So basically, so check every single value and see if it's an object. If it is an object, then go ahead and deep copy that object. Otherwise, return that value. Cool. So let's do that. So the way to get the keys of an object is this function called object.keys. So by doing object.keys and passing in that object, we now have an array full of the string values of the keys in that object. And so what we're going to do is we're going to iterate through those keys, check to see if the value is an object. If so, we'll go ahead and clone that. Let's not worry about functions or any of those other things for now. Otherwise, just return that value. So let's have this for loop. And do that. So first, let's define the new object that we're going to return. And let's just start with an empty object for now. And so now we have to check to see if each of these values is an object. If so, copy it, otherwise return. So how are we going to check the type of a particular key? Yeah, exactly, that type of operator. So we can do if the type of obj, and then pass in that keys. So what do we want to check against? All right, what am I doing wrong here? Yeah, we should always use that 3 equal signs. In this case, it wouldn't matter, but we should just get in the habit of doing that. And so if you notice here, we actually have bracket notation within bracket notation. That is totally fine. Cool. So if something is an object, what are we going to turn? We can do object, new object with that key. Equals what?
Oh no, I'm sorry, deep copy.
Yeah, let's actually deep copy that value Q2. Otherwise, we can just set it equal to the other key. And then at the very end, we can just return that new object. Cool. Anybody see any bugs? Candy opportunity. All right, let's just go ahead and test this. So let's do copy O, then update O, O.obj.key, let's set it to new key. O3.obj.key. Get rid of that. All right, so moment of truth. Key rather than new key, so we did it. Whew. All right, any other questions about objects, mutating, references, any of that stuff? No? Great. Arrays as well are also stored by reference. So if we were to do the same exact example, and rather than updating the object, we updated that array, we would end up with the same exact results. And so if we were to update our deep copy function to also take care of arrays, all we have to do is also check, rather than checking object, also check against arrays or any other data types that we want to check. Cool. Let's move on to prototype inheritance. So what exactly is prototype inheritance? Well, so non-primitive types have a few properties and methods associated with them. So array, we have this thing called array.push, which will add values to an array. So say we have something like an empty array. If we did array.push some value, then array now has something in it. If we were to push another value into it, it now has 2 values in it. So array.prototype.push is some method that we have available on all arrays that just adds new values to an array. Another one would be like string.prototype.to uppercase. So say we were to have some string. So if we did stir.to uppercase, now we're left with a new string with all uppercase. So these are just functions that we can invoke on any non-primitive that gives us something else. That is available to all non-primitives of a given type. So each object stores a reference to its prototype, meaning it knows about all of these methods, and it stores a reference to that object in order to know where these methods, the code to actually run that lies. And say we have a prototype chain where there are a bunch of different methods of the same name. Whichever one is bound most tightly to the instance has the priority. So say we have an object and an array, where array is the, so say we have a value that is of type array. Up the prototype chain, we have arrays. Its prototype is array. That prototype is object. Say we have the same named method on both of these. If we call that method the one that's bound most tightly, the array will take priority. So let's actually show that. So say we have something like that R. So array, it has a reference to its prototype. So if you did array dot double underscore proto double underscore, we see this large object with a bunch of different functions. And so we see down here push, which is that one that we invoked earlier. So this is exactly how it knows where that push implementation is. And so we can do array.proto.proto and go even farther up the chain. So this one has a bunch of other ones, toString, value of, whatever. And if you notice, both the array's prototype and its array's prototype's prototype have this method called toString. And if I were to invoke array.toString, which one of these is going to actually get called? The second one? Which one is the second one? .proto.proto. So actually the opposite. So since the toString on the array prototype is more specific than the toString method on the object prototype, this one is going to get invoked because it's more specific. Because an array is an array and it's an object, but it's more specific to call it an array than to call it an object, so it's going to invoke the one on the array. Does that make sense? Anybody have a question about that? It's an important concept and a little bit confusing at first. Cool. So most primitive types have object wrappers. And so we talked about how primitive types don't have any methods associated with them. But primitive types also have wrappers that have prototypes associated with them. What the heck does that mean? So if I were to do 42.toString, it's going to be like, what the heck do you mean? 42.toString, right? I told you that these primitive values don't have methods, and so 42.toString doesn't really make sense. But say I were to do this thing const num equals 42 and did num.toString, that will actually do something, and that's a little bit strange. So this is another one of those JavaScript interesting behaviors, because all of the primitive values have wrappers that give them access to a bunch of methods, and JavaScript will automatically do what's called boxing for you, which is says, hey, like I know 42 is a primitive, but if you call this toString method, I know what you mean. I'm gonna box this 42 number with this prototype that has a bunch of these methods on it. So if I were to do 42.toString, that would make sense. And if I do num.proto, that actually exists. But 42.proto does not. Does that make sense? Another way to find out if a value is an instance of some type, you can do this thing called x instance of number, and that would return false because x is actually not of type capital number. It's just boxed around in that number object for your reference. Does that make sense? Again, not something you're going to use every day, just something that is helpful to know in case you run into these strange corner cases. Cool. So why would we use a reference to the prototype? And what is the alternative there? Anybody care to give a shot at that? So this is going back a little bit to deep copying versus shallow copying.
So maybe if the initial object is massive,
Uh-huh.
and then you just want to do something light after it.
Yeah, so if the initial object is massive, like what happens then? So the alternative is basically to clone to deep copy every single prototype every single time you create a new value, which is safe because that number and all of its methods are all encapsulated within that specific variable. But it's also a little bit expensive in both performance because you have to do that deep copy every single time, and also of memory because that object starts to get pretty large. And if you have an array of like 100 different things, all 100 of those, deep copying every single prototype gets pretty big. And so what is the danger of storing a reference to the prototype rather than copying the whole thing?
I guess if you change it, then someone else is not going to expect it to be changed.
Yeah, exactly. If you change it, then it changes for every single value of that type. So let's do that really quick. So say we have, so we still have num, which is equal to 42, right? And if we do num.toString, what do we expect to come out? 42 is a string, right? But say some devious programmer was doing this thing where he did number.prototype.toString, and you actually override that to be some function that will return 100. Now what happens if I call num.toString? Wait a second. So that could have some dangerous penalties, right? So if I were to change the prototype of the number class, even though num was declared 100 lines prior to be the number 42, and we tried num.toString here and it returned 42, if we were to change the prototype later, it affects everything that has ever happened. So num.toString now starts returning 100, and everything that will happen. So if I were to do everything in the future also has those consequences. So changing the prototype is something that is very dangerous and is recommended against doing. Does that make sense? Cool. So let's actually take a short break. All right, welcome back. So let's talk about scope now. So what the heck is scope? So scope is a term that's talking about variable lifetime and how long these variables actually exist. And so there are a couple different types of scoping. There's lexical scoping, which is that keyword var that you might see if you're reading old JavaScript. And there's block scoping, which refers to how things like const or let are scoped. So lexical scoping is basically saying, hey, give me a variable, and it'll exist for as long as since it was declared, all the way until the end of a function ends, or the file if it's in a file. Whereas the analog would be block scoping, where it behaves a lot like something behaves in C, where basically a variable will be around from when it's declared until the next end curly brace is reached. And so that there's the big difference between var and const and let. And the difference between const and let is that const is something that can't be updated. Meaning if I set a variable to be a constant, it means I'm not going to update that reference later, whereas let can be updated. So if I were to do const, this is a const, and set that equal to something like 50, if I were to say this is a const, and try to update that to be 51, I'm going to get an error, actually, that says, hey, you called that a const, but you're trying to change it. That's not OK. And so no matter how I want to change it, say I do that plus plus or something, that's also going to fail. Whereas if I did something like let this is a let equal to 50, I can go ahead, or 51. I made a typo, but I can just say, hey, it was a typo. This is a let. Let me change that to 50, and we're all good. And I can also do that plus plus, or change it however I want, and it will actually update that. Note that I said the reference can't be updated. I did not say anything about things being immutable. So if I did const obj equals this empty object, if I can't update it to be point to a different object. So if I tried to do obj is something else, I'm going to say, hey, you called this a constant, you're trying to change it. But I can still do obj.a and set that equal to a, because why? Anybody care to tell me why? Exactly. So the pointer is still pointing to the same object. The reference has not changed. So we mutated that object, but it's still pointing to that same place in memory. It's still pointing to that object that exists over here, and that reference has not been changed. Does that distinction make sense to people? It's a pretty important one. Cool. So let's play a little bit with these variable lifetimes. So I said before that if I tried to do something like this, what happens here? Error. Why? Because it's a constant and we can't update a constant. And we can confirm this. Oh. It'll actually tell us, hey, type error, you call this a constant variable, but you're trying to assign it. That's not OK. But if we did this is OK because the reference to that object did not change. We just mutated it. On the other side, if we did something like let, this is a let equal to 51, and then want to change that later, equal to 50, that's totally OK. But if I actually tried to reassign, so let this is a let, if I tried to do this again, it's going to yell at me because it's saying, hey, you already declared something called this is a let. You cannot declare that again. And so constant let actually protect you from declaring something with the same variable name twice, which is something that var does not give you. Cool. What do you guys think would happen if I tried to do this? Anybody care to guess? Undefined. So let's try to run it. Error. So since these things are block scoped, it means the variable is declared at the line that it is written. And if we tried to use it before then, it actually does not even exist at all. So if I tried to console log something called this is a const here, remember the JavaScript interpreter is just reading down, and it won't see like, hey, what the heck is this is a const? I have no idea what that is, so I'm just going to error here. Same thing if I tried to do this is a let here. That will also error with the same error.
So what is line 14 error at?
Why does it error? Because we're trying to declare two variables with the same variable name twice. So we have let this is a let equal 51 here, and we try to do it again, and it's saying, hey, you already have a variable called this is a let, so I'm not going to allow you to do that again. So it's going to be this error right here.
It's just the instantiation of it?
Yeah, it's saying like, basically I'm saying, hey, give me a variable called this is a let here, and then a couple lines later I'm saying, hey, give me a variable called this is a let, and JavaScript says, hey, like you already have a block scope variable called this is a let, so I can't give you another one. However, if I tried to just update it like this, that's totally OK. Any other questions here? So the other thing we said, we can have these things called var. If I did var, this is a var equal to 50, that's fine. I can update it. That's also fine. I can also do this. And that won't yell at me. So vars are older ways to declare variables, and they don't have the same protection that let and const do. You can override them like this, and it's totally OK. And you can actually declare a whole new variable with the same variable name, and that's also OK. And something, yeah?
What happens there?
It just,
Does it overwrite the original one?
yeah, so that's, so if I tried to run this, it will update the old one. It'll just replace that value. It's actually called shadowing, where you create a new variable with the same variable name, which basically just overshadows that old one. So it's as if that other one didn't exist. Does that make sense? Cool, so check this out. So this errors, and we know this errors, but say I were to do this. You'd expect this to also error, but it actually does not. It returns undefined. So this is another weird thing about JavaScript. This is called hoisting. And so certain things are hoisted, which it means basically it takes the definition of something and hoists it to the very top of the file and does that first. And a few things are hoisted. Var, actually the declaration of the creation of an empty variable are hoisted. Function definitions are hoisted as well, but const and let are not. As we saw, if we tried to access the variable name of a const or let, then it errors. But with the var, the declaration of that variable is actually hoisted. And we can talk a little bit more about how that works in a second, but let's actually play with it a little bit more. So function definitions are hoisted. So let's clean up this file a little bit. So let's call this new function called so this is console.log. So I define this function called this is hoisted at the very bottom of the file. And all it does is it console logs. This is a function declared at the bottom of the file. But something very interesting is at the very top of this file, I can call it. And that will actually work. And so that is what's called function hoisting. The behavior whereby a function definition declared at the very bottom of a file is actually available for use at the very top of the file as well. But this does not work in other cases. So say I were to do something like this. So who can tell me what the difference is between line 21 and line 25? They look pretty similar, right? Yeah.
So line 25
Mm-hmm.
be reassigned.
OK.
So you can't reassign it to a different function, but line 21 could be reassigned for that same variable name.
Yep. So repeating for the camera, line 25, this is not hoisted, is declared as a constant, so it cannot be changed. Whereas line 21 is declared as a function, and so it can be changed, which is absolutely correct. But What happens if I try to do this up here? Yeah, so we're gonna get an error. This is not hoisted, is not defined. Why? Because as we talked about earlier, these things called consts are not available for use until they're actually declared. So certain things are hoisted. var, so the declaration of these variables are hoisted. Function definitions, if they're declared like this, are hoisted. But if we create what's called an anonymous function, a function without any name, and set that equal to, or assign that to be a constant, then that constant is not created. Does that make sense? So what happens if I try to do this? Yeah, so same thing. It errors. What happens if I try to do this? What's hoisted? The function? So notice, oops. So notice the difference in the two errors. They're actually not the exact same error. So who wants to give a guess at what's going on here? So when I declared it with the let, it's saying reference area, reference error, this is not hoisted, is not defined. Whereas when I use a var, it says type error. This is not hoisted, is not a function. Why might that be? Yeah.
So in the first case, the variable is undeclared,
Uh-huh.
whereas in the second case, it's declared, but doesn't assign a value to it until it gets to that line.
Exactly. So repeating for the camera, and I'll bring up the code as well. So down here, so the first time when we declare this with a let, it's not declared at all. This variable does not exist at all. So this is not hoisted. The JavaScript does not know what that means on line 1. But when I use a var here, remember, it hoists the declaration of this variable. So it creates a variable called this is not hoisted. However, it does not assign it a value until line 25 is executed. And so at line 1, this is not hoisted exists. It's just equal to undefined. And if I try to invoke it like a function, it says, hey, this is an undefined variable. I can't invoke it like a function. This is a type error. And so even though both of these things errored, the reason that they errored is slightly different. In case 1, when they're declared using a const or a let, that variable just does not exist at all. However, when we declare it using var, the variable exists. It's just undefined. And so if we try to invoke it like a function, then it says, hey, like, this is undefined, it's not a function. Does that make sense to everyone? So why does this happen? How does this happen? And the reason is actually how JavaScript is executed. So there's 2 phases in the execution of a JavaScript file. So before executing any code, it has all of the text in front of it, but it hasn't executed anything. It just reads the entire file. And what's it looking for? Well, 1, it's looking for anything wrong with the file. So say, like my very first example, when I had an array and it was missing a comma, that's something that's caught in that first reading. It says, hey, like, this looks like an array, but it's not quite right. Like, I see this thing that I'm not expecting. I'm expecting a comma here. And so that's one thing that's caught. Other things, maybe it will add some semicolons for you and stuff like that. And then any function definitions just get saved in memory. It says, hey, this is a function. Let's put this in memory, so if somebody wants to use it at line 1, they're able to. Variable initializations, if they're lexically scoped, or if they're lexically scoped, they will be declared, but they will not be initialized. Meaning anything declared with var will be declared, like this variable exists, but it's not going to be set equal to anything until later. And then there's a second phase called the execution phase, whereby the code is actually run, it's executed. And so that is when things like const or lets get invoked, or get both declared and initialized. Does that make sense to everyone? Anybody have any questions on scope? So why might we take advantage of this scoping? Does it seem like a feature? Does it seem like a bug? Anybody care to guess? There's no correct answer to this. It's completely opinion. Yeah?
So if you've got a controller with math functions in it,
Uh-huh.
you can call ones that are way down in the file so that you don't have to write all your code in one giant function.
Yeah, so one thing might be we can have these function declarations at the very bottom, and then we can use it at the top. And so that might be good for code organization. Like somebody reading your code would know, hey, if I'm looking for these functions, they're all going to be declared together at the bottom. They might be used everywhere, but all of the function declarations are all going to be here. So that might be a feature because it's good for organization. So say we were to play devil's advocate. Who might see this as a bug?
Well, I'm struggling to see why you'd be able to declare a variable with the same name within the, looks like the same scope
Uh-huh.
using var. I find that very confusing.
OK, so the question is, like, why can we declare two variables with the same name when they look like they're in the same scope, specifically with this var keyword? This is another thing where it's a bug/feature that a lot of people used. And so if JavaScript were to be updated and that bug/feature were to disappear, a lot of code would break. So a lot of people took advantage of this. And basically, it's the same thing as like y is type of null object, just because it is. And we can't change that because people rely on that behavior. I know it's kind of an anti-answer, but does that kind of make sense?
I'm going to try to avoid it.
Yeah, you should definitely. So there's not really a good reason to use var anymore. With ES6, everything supports constant let now. And so I've been using them in all of the examples, except for these. And I think you should definitely use them as well. The reason I'm teaching var is one, so if you see this, you know what's kind of going on. And because a lot of legacy code, a lot of code written 5 years ago, 10 years ago, uses var just because it was the only option. One thing that I didn't mention earlier is that you can also declare a variable like this. So this is another way of declaring a variable. This creates a global variable. It's something that you probably won't see that often. There's really no reason to do it. But in case you ever see that, that's what it is. So if you declare a variable without giving it a keyword like let, const, or var, it creates it globally. But there's no reason for you to use this, really. It's just if you ever see it, that's what it is. Any questions at all about scoping? It's a pretty important concept. And for online folks as well, remember you can post in Slack, and the staff will either field those questions or ask them to me. Cool, so let's move on to our final topic of the day. So the global object, so the way these things all work is basically in any given runtime, there's this thing called a global object. And so all variables, all functions are actually keys or parameters or methods on the global object. So in browser, there's this thing called a window, which is the global object of a window. So this is a browser environment. And if I type window, I see this thing. And it has a lot in it, so much that it froze my computer. There we go. Oh, no. But basically, the window is this global object, and on it, there's all sorts of stuff. So we see $0, $0, So any variable that you declare in this console gets put onto this global object called a window. And so actually, let me open a brand new browser tab. And and we'll get a little bit of a cleaner window. So the reason that we saw these things called $0, $whatever, is because I opened the dev tools on the same tab as my lecture slides. And the way that Google Slides works is, since it's something dynamic on the web, it has to be using JavaScript. And since it's using JavaScript, obviously it's creating a bunch of functions, it's creating a bunch of variables. And all of these things end up on the window object. And so when we inspected the window object of that particular tab, there was a bunch of stuff on it because that's how Google Slides was working. And when we created a new tab, this is a brand new tab, and therefore no JavaScript has been executed. So there's a lot fewer variables and stuff on this new tab. And so whenever we create new variables, so say do const x equals this is a new variable, we see x is this. We can also do this window dot x. I declare it as a const. So the way that browser windows handle these block scope variables is a little bit different. So we'll use var for the sake of explanation. So when I create this new variable called var y, it is the exact same thing as window.y. And so if we inspect window, we see a bunch of things that are part of the JavaScript API, the browser API, all of these things. And if we go all the way to the very bottom, so this is stuff that is created in the new tab, elemental P, Q, R, S. We see this y here. So part of that window object is that variable called y that we stuck on the window. And so even though we declared it with var y equals something, it ended up on that global object. And that's how JavaScript keeps track of all of your variables and stuff. And so what happens when we're in the node environment and we type window? Window's not defined. And it's because in the node environment, the global variable is not called window. It's actually called global. And if we type global, we now see all of these things. And a lot of this will overlap with that window object in the browser. But since the browser API has things in it that is not necessarily used in the command line, stuff like give me a DOM node or give me CSS on this DOM node, stuff like that, that doesn't really make sense in the command line interface. Therefore, those things are not on this global object. And then if we try to type global here in the window, that doesn't really make sense either. There's another thing that's just kind of important to know, but you might not ever take advantage of it. But does that make sense? Cool. So let's move on to something that we'll discuss a lot more in the next lecture, but I'll go ahead and introduce the concept in this lecture and leave you with a little bit of a teaser. So who here has heard of a closure before? So closures are actually one of the things that JavaScript programmers hate the most because it's a very, very difficult concept to learn. Mostly because it's always taught somewhat poorly. And so next time I'm going to try to do a good job of teaching you, but I'm going to show you right now the problem that a lot of people face. And so what closures are functions. It's the behavior whereby functions that refer to variables declared by a parent function still exist. And it's possible because of scoping. What the heck does that mean? I'll explain it in the next lecture, but let's go ahead and explore what this actually means. All right. So let's do this. So first thing I'm going to do is I'm going to declare an empty array called array, and I'm going to fill it up with a few values. 5. And I'm using var here intentionally. And let's push on a function that does this. And then all right, so what the heck did I do here? So I declared a function called makeAFunctionArray, and all it does is it creates an array, fill it with functions, and then invoke one of them. And so if I were to call this, I get back an array full of functions, right? And what do we expect those functions to do, each of them? Print a number, right? And so what should happen is I should be able to march through this array, invoke each of those functions, and get back something that counts, right? Basically. So let's see what happens. So I'm just going to access that first one and invoke it. And we expect it to print out 0. Whoa. So that there is one JavaScript's worst enemy, or a JavaScript programmer's worst enemy, because it's somewhat unexpected. And as we'll see in coming lectures, that is actually as expected. So I'll leave you guys on that cliffhanger for next time, and we'll go ahead and officially end lecture. I'll stick around if you have any questions.